Hi everyone, this is Dr. Nak. Today we're going to learn about quadratic inequalities. So here are our goals for this section. Number 1, solve inequalities that involve quadratic functions. In case you forgot what the quadratic functions look like, they're nothing but functions of the form f of x equals ax squared plus bx plus c, where a does not equal to 0. Now if you recall, graphically they're nothing but parabolas. Goal number 2, graph the function f of x equals ax squared plus bx plus c, and from the graph, determine where it is above the x-axis, which is same thing as finding where f of x is greater than 0. And goal number 3, graph the function f of x equals ax squared plus bx plus c, and from the graph, determine where it is below the x-axis, which is same thing as find all the x values where f of x is less than 0. And goal number 4 is graph the rational function r of x equals p of x over q of x, and from the graph, determine where it is above the x-axis and below the x-axis. And our goal number 5, we want to find where f of x is greater or equal to 0, or just strictly greater than 0, or f of x is less than or equal to or less than 0, and do the same thing for our r of x without graphing. It sounds like there are a lot of things that we're going to do, but it is not as bad as you think. So let's do some examples. Example 1, solve the inequality x squared minus 4x minus 12 is less than or equal to 0, and graph the solution set. So here's what we're going to do first. Let's do this graphically, meaning we're going to graph this parabola, which is f of x equals to x squared minus 4x minus 12. Then let's find out where the graph is going to be below the x-axis. That's same thing as saying our function is less than or equal to 0. But anyways, to give it a rough sketch, you know what? Let me just call f of x to be x squared minus 4x minus 12. And don't forget what we're doing. We want to find out where this function is going to be less than or equal to 0. But anyways, to get a rough sketch, let's first get the x-intercept and the y-intercept, and let's get a vertex. So here is our x-intercept. How do you find it? Is you're going to have to set y equals to 0, and then you're going to have to solve for x. All right, so then what we're going to get is x squared minus 4x minus 12 equals to 0. Now, how are we going to solve for x? Well, we're going to have to factor. So here we're going to have x and x. Sign's going to be plus minus. How is this going to factor? Minus 6 and then plus 2. Is that going to work? Yep, that should work. So that implies that x plus 2 is 0, or x minus 6 is 0. So that implies that our x-intercepts are going to be x equals to negative 2 and x equals to 6. So let me just box those two. And let's get ourselves the y-intercept. Now how do you find it? Is you're going to have to set x equals to 0 and solve for y. Okay, so if I do that, then what do we get? Y equals to 0 squared minus 4 times 0 minus 12. So that implies that y equals to negative 12 is going to be our y-intercept. Okay, so now let's get ourselves the vertex. Now, the formula for the vertex was negative b over 2a, and then f of negative b over 2a. So in this case, our a is 1, and then b is negative 4, and then c, although we're not going to need c to compute the vertex, but what the heck, c is negative 12. Okay, so let's first go with the x-coordinate of our vertex, which is going to be negative b over 2a. So that's same thing as negative b, which is negative 4 over 2 times a, where a is 1. So you're going to have 4 over 2, so which is just going to be 2. So that's going to be the x-coordinate of the vertex. And then f of negative b over 2a, so that's going to be the y-coordinate of our vertex. So this is going to be f of 2. So this is gonna give us 2 squared minus 4 times 2 minus 12. So what the heck is that? Negative 16. All right, so it looks like, let me just write it over here. So therefore our vertex is going to be at 2 comma negative 16. Okay, so let's give ourselves a little rough sketch. So here's my little rough sketch for our function f of x. Now don't forget what we're doing. Great, we're able to graph it out, but we can't stop there because look at the question. We want to solve the inequality. Solving means find all the value of x where our function f of x is less than or equal to 0. Now, since y equals to f of x, what we want is find all the value of x where our function f of x sits below the x-axis. Okay, so keep that in mind and let's look at our graph. Okay, so here is our x-axis. We want to find set of all x values where the graph is below the x-axis. So where is it? Well, starting from x equals to negative 2, I see that our graph is below the x-axis. Okay, so how far does the x value is going to go? From negative 2 all the way up to x equals to 6. So in this region here, our graph is going to dip down the x-axis. So that's exactly what the question's asking you to find. So let me just write that out. So I'll write it like this. Therefore, our f of x equals x squared minus 4x minus 12 dips down the x-axis, or same thing as less than or equal to 0, on negative, starting from negative 2. Now notice that our x-intercept is going to be included in our solution set because we're given the less than or equal to. Equal to means that if you're going to have to include our x-intercept. So here you're going to write it as negative 2 less than or equal to x less than or equal to 6. All right, so in terms of an interval notation, it will be from negative 2 to 6 in a closed bracket, or in a set builder notation, we'll write this as set of all x such that negative 2 less than or equal to x and then less than or equal to 6. All right, so that's going to be our answer. Now, to graph the solution set, because I asked you to graph the solution set, correct? So just bust out the little number line. So let me just write it like this. So let's go from negative 2 to 6. So set of all x values that's between from negative 2 to 6 are going to be your solution set. So the answer here, close bracket negative 2 comma 6, and the set builder notation, set of all x such that negative 2 is less than or equal to x less than or equal to 6, and this graphical notation for the solution set, they all mean the same thing. Okay, but anyways, just because I wrote everything out, I'm just going to box everything here. So this is going to be our final answer. For example 2, let's try to solve the same problem that we just did, but without graphing. So what I want to do is let's try to solve this just by algebraically. Now, please keep in mind what the question's asking for us to do. It says solve, meaning find the value of x where this whole entire function is going to assume negative. So whole entire y values is going to be negative. That's same thing as saying less than or equal to 0. But here are some steps that we're going to follow. So step number 1, factor everything out completely. So if I do that, let me just write down our original function, x squared minus 4x minus 12. And then I'm going to set that less than or equal to 0. So if I factor this out, then you're going to have x minus 6, and then x plus 2 is going to be less than or equal to 0. Now, step number 2, find the x-intercept and vertical asymptotes if there are any. Now, in this case, since this is just a polynomial, there are no vertical asymptotes. However, we do have x-intercepts. Now, the x-intercepts are where x minus 6 is going to go to 0, and then x plus 2 is going to go to 0. So our x-intercepts are x equals to 6, and then x equals to negative 2. So let me just box that. Step 3, make a chart for all the x-intercept, vertical asymptotes, and f of x. All right, so this is what's going to happen. Notice that our whole entire function is the product of x minus 6 times x plus 2, right? And then we're able to squeeze out the x-intercept by using x minus 6 equals to 0 and then x plus 2 equals to 0. So the first line is reserved for the first factor of our f of x, which is x minus 6. And the next line is for x plus 2. And finally, the last line is going to be our whole entire function f of x, which is same thing as x minus 6 and then x plus 2. Well, this is exactly the same thing as x squared minus 4x and then minus the 12. Just go with it. Okay, so first jot down the x-intercepts. Pretend that that's like a number line. Okay, so x equals to 6, that will be maybe here. All right, and then x equals to negative 2. Let me just write it over here. Okay, and then just jot down all the x-intercepts and also the vertical asymptotes. However, we don't have a vertical asymptotes for this particular problem. But anyways, I'm just going to write it as negative 2 and a 6. Next step, what we're going to do is this. Pretend that this is a number line. Now, what you want to do is on the left of 6, right? Is my sign's going to be positive or is it going to be negative? So to do that, for the first number line, which is the line for the x minus 6, pick any number that would lie in this region, which is from negative infinity all the way up to 6. Pick any number that's going to lie in there. How about a 0, right? 0 would be like maybe over here somewhere because that's negative 2. So 0 is certainly in this interval. Okay, so if I plug it in x equals to 0 in place of x, notice that this whole entire region here, they're all going to assume negative values. And then if I plugged it in, any value that's bigger than 6, let's just say 7, if I plugged it in 7 in place of x, notice that this whole right-hand side of 6 is all going to become positive values. So let me just write that out. So I'm going to have a negative here, negative, 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 and then right of 6, we're all going to assume positive. All right, now we're going to do the same thing for the line x plus 2. Now, here is our x-intercept. Now, let's pick any number that's going to be in this region, which is going to be less than negative 2. So how about negative 4? So let's plug it in negative 4 in place of x. So I have a negative 4 plus 2. Is that going to give us a positive value or negative value? Well, that's going to be negative, isn't it? So from the x-intercept of negative 2 on the left-hand side of it, they're all going to assume negative values. Now, on the right side of our x-intercept of negative 2, just plug it in any number. How about a 0? 0 would be in this region. If I plugged it in 0, we have a 0 plus 2. So all the values are going to be positive from negative 2 on. So here I'm just going to write it as positive, 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 positive. I don't know why I'm putting so much positive on there, but it doesn't matter. Okay, now here is the thing. Okay, so now let me just do this. Let me just jot it down. All right, so now let's take a look. Look at the third line. Third line is saved for x minus 6 times x plus 2, right? So basically I'm multiplying this factor and then this factors together. That's same thing as multiplying all the signs together. All right, now from negative infinity all the way up to negative 2, I have a negative times the negative. Now negative times the negative, that's going to give us a positive, doesn't it? So in this region here, we're going to have all the positive values. Let me just write that in red. All right, now in the interval between negative 2 and a 6, let's see. The top line assumes negative, and then the second line assumes positive. So negative times the positive, it's going to give us a negative. So on the interval from negative 2 to 6, all the values between that are going to be negative. Now we're going to do the same thing on the interval from 6 to positive infinity. Now the sign on the top is positive. sign on the second line is positive. Positive times the positive is another positive. So I'm just going to write that sign like that. Okay, now there is a point. Okay, so notice again that the bottom line is saved for our function f of x. Now let's go back to what the question is asking for us to do. Look at it. I want to solve for our whole entire functions to be negative. What are all the x values where my whole function is going to assume a negative value? All right, so remember, this whole bottom line is our function f of x. Now, where does that assume a negative values? Well, all the negative values that I see are on the interval from -2 to 6, isn't it? So, boom, we're done. So here, the bottom chart is telling you that, oops, let me just write it like this. X squared minus 4x minus 12 is less than or equal to 0 or negative on the interval from -2 to 6. Isn't that exactly the same answer that we got in example 1, where we graphed it out and we analyzed it? But anyways, so in a set builder notation, this is same thing as settable x values such that -2 is less than or equal to x, and then less than or equal to 6. And then again, if you want to draw this on the number line as a solution set, you can go -2 to 6, put a closed bracket, and then just shade in between, and we get the same exact answer as in example 1. Well, we better, or we did something wrong. But anyways, here it is. So this is how to do it, how to solve an inequality without graphing, just straight up looking at the chart and analyzing it. Now let's take a look at example 3. Solve x squared plus x is strictly greater than -1 by graphing. And guess what? In example 4, we're going to do this just by algebraically. But anyways, let's start on this. So step number 1, let me just rewrite this as x squared plus x, and then plus 1 is greater than 0. All I did was I just added 1 to both sides of the inequalities. Okay, so now pretend this whole thing is going to be your f of x. All right, so what we're doing is we want to find the value of x where f of x is positive. And graphically, we want to find set of all x values where the graph is going to be above the x-axis. Okay, so again, we're going to do the same thing. Let's get our x-intercept and a y-intercept, and then let's get ourselves a vertex. So let's go with the x-intercept. So what do? We need to set y equals to 0, and then we're going to have to solve for x. Okay, so then here we're going to have x squared plus x plus 1 equals to 0. So let's see, can we factor this or what? X, and guess what? You cannot factor this, right? Because look, only possible factors of 1 is going to be 1. So I'm going to have a 1 and 1, and sign better be plus plus. Now notice that if I multiply that out, we're going to have x squared and then plus 2x, which we don't have. So guess what? We don't have any x-intercept for this particular problem. All right, so let me just cross that out. Cannot be factored, so that implies that no x-intercept, which means that you're going to have a floating parabola, meaning your parabola is never going to touch nor cross the x-axis. All right, but anyways, let me just jot that out. Now let's go with the y-intercept. Now, how do you find y-intercept? Is you're going to have to set x equals to 0 and solve for y. All right, so then you're going to have y equals 0 squared plus 0 plus 1, right? So that implies that y equals to 1 is going to be our y-intercept. All right, now let's go with the vertex. Vertex formula is negative b over 2a, and then f of negative b over 2a. Okay, so here our a is 1, b is 1, and then c is 1. I'm just looking at our function f of x. All right, so then negative b over 2a this is going to be negative 1 over 2 times 1. So our x-coordinate of the vertex is going to be negative 1/2. Now let's go with the y-coordinate of our vertex, which is f of negative b over 2a, which is same thing as f of negative 1/2. All right, so then this is same thing as negative 1/2 squared plus negative 1/2 and then plus 1. So this is going to give us 1/4 minus 1/2 and then plus 1, which is same thing as 1/4 minus 2 over 4 and then plus 4 over 4. I'm just putting everything in a common denominator. So then what the heck do we get here? We're going to have a 4 in the bottom. 1 minus 2 is minus 1. Minus 1 plus 4 is 3. So we're going to have 3 over 4. All right. So it looks like our vertex is going to be at negative 1/2 and then 3/4. Okay, so now let's give ourselves a little rough sketch. So here is our rough sketch for our function f of x, which is x squared plus x plus 1. Now again, notice that there are no x-intercept as we expected. Now let's understand what the question is asking for us to do. I want to find out all the value of x where our function of x is going to be strictly above the x-axis. That's same thing as saying f of x is strictly greater than 0. So let's take a look. Here's my x-axis. Now look at our function f of x though. Do you see that no matter what the value of x is, our function f is always going to be above the x-axis no matter what? So the way we could answer this is this. So therefore, our function f of x is always going to be greater than 0 for any value of x, or I should say for all value of x. For all x, which means that our answer is going to be all real numbers. All right, so we can just write this as in a set builder notation. We can write it as set of all x such that x is all real numbers. Now, if you want to graph this out on a graphical solution set, then you're going to have a negative infinity to infinity here, and you're going to be shading this whole entire number line. All right, so that is going to be our answer. Now, for example 4, for the next example, let's just do this by algebraically. No more graphing. So here's example 4. Solve the same inequality, x squared plus x plus 1 is strictly greater than 0, algebraically. Okay, so we're going to follow the same exact step that we did before. So step 1, factor. But the thing is, were we able to factor this over the real number line? I don't think so. So this cannot be factored. All right, so then that means what then? We cannot find any x-intercept. And if we did the same thing as what we did before, next step was to find the x-intercept and the vertical asymptote. So in this case, there aren't any. Oh no, there are none. All right, and the next step was what? Step 3 was to make the chart for the x-intercept and our f of x and a vertical asymptote, wasn't it? So in this case, we don't have any x-intercept, we don't have any vertical asymptote, so we're basically just looking at our good old function f of x now. So the only line that we can get out of it is just one, which is, let me just write this out. So the line here is nothing but our x squared plus x and then plus 1. No x-intercept, which tells us that no matter what value that you're gonna pick and then plug that test value into the function f of x, your sign's gonna remain exactly the same. There is no sign changes from positive to negative or negative to positive. All right, so pretend that this is the whole entire real line, right? Pick any number in between. How about a 0? 0 is always cute, isn't it? So if I pick 0, because 0 is in here, plugged it into our f of x, what do we get? We're going to have 0 squared plus 0 plus 1, which is positive 1. So no matter what, our sign's going to be positive on the whole entire real line. Okay, so now let's analyze what the question's asking for us to do. What we wanted was where our function f of x, which is x squared plus x plus 1, is going to be positive. So look at it. Aren't they positive on the whole entire real line in this case? So that is going to be our answer. So we're going to answer that as x squared plus x plus 1 is always going to be positive for all x values. So for negative infinity to infinity, in a set notation, you can write it as set of all x such that x is all real numbers. And then on the number line, just like what we did before, here's my negative infinity to infinity. You're going to be shading this whole entire region. So this was a little bit of a strange ways to do it algebraically, but hopefully it makes sense. Let's take a look at example 5. Solve x minus 3 times x squared minus x minus 12 is going to be less than or equal to 0. So here what I'm going to do is this. Let's just do this by algebraically without graphing. All right, so again, let me just write down all the steps. Step 1, factor everything out completely. All right, so let me just rewrite our original function x minus 3 and then x squared minus x and then minus the 12. All right, so then here, what do we get? X minus 3 is done. Now, I think we can factor this one. We're going to have an x and an x, plus and a minus. How about the 4 and a 3, just like that? Is that going to work? I think so, right? X squared and then minus 4x plus 3x and then minus 12. Yep, that should work. Oh, let me just insert less than or equal to 0 and then less than or equal to 0. Okay, so the next step is this, right? Find the x-intercept and a vertical asymptote. But the thing is, we're given the polynomial, so there are no vertical asymptotes. So let's just go with our x-intercept. So our x-intercept are going to be x minus 3 is 0, x plus 3 is 0, and then x minus 4 is going to be 0. So our x-intercepts are x equals to 3, x equals to negative 3, and x equals to 4. So we got 3 x-intercepts going on. All right, now step 3, make a chart for our x-intercept, vertical asymptotes, which we don't have any, and our function f of x. So in this case, we should have 4 lines because look at how many factors of f of x we have. We have x minus 3, and then x plus 3, and then x minus 4, and then our whole entire function f of x is going to be at the very bottom. So here, let me just write this as x minus 3, x plus 3, and then x minus 4, and the product of all of it, x minus 3, x plus 3, and then x minus 4, which is exactly the same thing as our function x minus 3, and then x squared minus x, and then minus the 12. All right, so now let's jot down our the x-intercepts. So x-intercepts are x equals to 3. So let me just write that as 3, and negative 3, and then positive 4. All right, so now what I'm going to do is I'm just going to jot down all the x-intercepts. Okay, so here we're going to have negative 3, 3, and a 4. All right, so ready to do this? So let's first take a look at the first line, x minus 3. Now, plug any values that's before 3. So how about a 0, right? So if I pick a 0 as a test point, if I plugged it in 0 in place of x, I'm going to have 0 minus 3, which is going to be negative 3. So in fact, it's just negative. So all the sign below the 3 is going to be all negative, and then above 3, we're going to have all positives. All right, now we're going to do the same thing for x plus 3. All right, so now here's my x-intercept. Pick any number that's going to be less than negative 3. So how about a negative 5, right? So if I plugged it in negative 5, in place of x, I'm going to have negative 5 plus 3, which is going to give us a negative. So here we're going to have all negatives. And then after that, we're guaranteed that we're going to have all positives. All right, to the right of negative 3. Now let's do the same thing for x minus 4. So, you don't have to plug it in, in order. You can always pick something that's bigger than 4 to start out with. So, you know what? Let's just do that. So let's pick any number that's bigger than 4. Let's just say 5. 5 minus 4, that's going to give us a positive value. So here we're going to have positive. That means all the rest of it has to be negative. All right. So now here comes the product of everything. Okay, so let's first look at from negative infinity to negative 3. Now we're going to be multiplying negative times a negative. So that's going to give us a negative. So here we're going to have all negatives. All right. Now on the interval from negative 3 to 3, we have a negative times a positive times another negative. So you got a negative times a positive, which is a negative. Negative times a negative is a positive. So on the interval from negative 3 to 3, we're going to have all the positive values. Okay, so which means that our function is going to lie above the x-axis. Now let's go on the interval from 3 to 4. Right, so in here, what kind of sign do we have? A positive times a negative. So here we're going to have our negative sign, which means that your function is going to dip down below the x-axis. Now the last one, from 4 to positive infinity, you have positive times positive. So everybody's going to be all positive in here. Okay, so now let's go back to what the question's asking us. What do we want? We wanted where that our whole entire function f of x is negative, right? So where are they negative? Well, I see that it's going to be negative from negative infinity to negative 3, and then also from 3 to 4, right? So let's write our conclusion. So therefore, our function f of x, which is x minus 3 x squared minus x minus 12, is going to be less than or equal to 0, right? So that tells you that you better have a closed bracket as on your interval notation. But anyways, so it's going to be negative from negative infinity to negative 3, close bracket, and then union, close bracket, 3 to 4, and then close bracket. Now, if you want to give a graphical solution set, then here's negative infinity. So let's just go with negative 3 and 3, 4, and then positive infinity. So in this case, we're going to have to shade this region and then close interval 3, 4. So here it is. So that is going to be our answer. So let me just box all of that. Here we go. All right, so here is our actual graph of our function f of x. So let's see if it makes sense. Now, notice that our whole entire function is negative, which means that our function dips down the x-axis from negative infinity all the way up to negative 3, right? And then also between the I don't know if you can see this very well, but only from 3, x equals to 3 to 4. All right, so it does make sense. Let's take a look at example 6. Solve x squared minus 25 all over x minus 3 is less than 0. So this is no longer a polynomial function now. This is in fact a rational function. But all the steps are exactly the same. So let's start. So step 1, factor everything out completely. So let me just copy down the problem. X squared minus 25 over x minus 3 is going to be less than 0. So I can factor the numerator as x plus 5 and then x minus 5. And then on the bottom, you're going to have a x minus 3. And that's going to be less than 0. Now, step 2, same thing. Find all the x-intercepts and the vertical asymptotes if there are any. So find x-intercept and the vertical asymptote. All right, so we do have x-intercept in this case. So our x-intercepts are where x plus 5 goes to 0, and then x minus 5 goes to 0. And our vertical asymptote is where x minus 3 is going to go to 0. So in this case, our x-intercepts are at x equals to -5 and x equals to 5. So those are our x-intercepts. And then our vertical asymptote is going to be x equals 3. So this is going to be our vertical asymptote. All right, now step 3, same thing. Make a chart with all the x-intercept and the vertical asymptote and our function f of x. So how many lines are we going to have here? I think we're going to have a total of 4. Do you see why? Because you have x plus 5, x minus 5, and then you got x minus 3. So that takes care of 3 lines. And then at the very end, we're going to have the whole entire function appearing. So let's make 4 lines. So the first line is for x plus 5. Next one, x minus 5. And then x minus 3. And finally, it's going to be x plus 5, x minus 5, whole thing divided by x minus 3, which is precisely our function, x squared minus the 25 over x minus 3. All right, so let's just do the same thing. Let's just jot down x equals to -5. So here it is. And then x equals to 5. And then x equals to 3. That's the word the vertical asymptote is. Does it look, is that in order? Yes, it is, right? Okay, now I'm going to jot down. Here's my -5, 3, and a 5. So let me just even make a little dotted line here. Now keep in mind that this is the vertical asymptote. We have a vertical asymptote here. All right, and then let me just make a little dotted line here. Okay, so now we're going to play with our signs. Now let's take a look at the first line. Let's pick any number that's bigger than -5. So let's just say 0. Plug it in place of x. We're going to have a 0 plus 5, which is going to give us a positive value. So on the right of -5, everyone is going to be positive. And that means that on the left of -5, everyone's going to be negative. All right, now let's go with x minus 5. All right, now plug it in any value that's going to be bigger than 5. Let's just say 6. Then you're going to have a positive value. So here on the right of 5, you're going to have a positive. Then everywhere else on the left of 5 should be negative. Now the vertical asymptote. Now we're going to do the same thing. So pick any value that's going to be bigger than 3. Let's just say 5. Right, plug it in 5 in place of x. We're going to have 5 minus 3, positive. So you're going to have positive on the right of 3. That means you're going to have all negatives on the left of 3. All right, now we're going to multiply everything out. So the first interval from -infinity to -5, you're going to have a negative times negative times a negative. So you're going to have negatives. All right, now let's go in the interval from -5 to 3, where 3 is the vertical asymptote. You have a positive times negative times a negative. So here we're going to have all positives. All right, and the next line, you're going to have positive, negative, positive. So you're going to have negative. So on the interval from -3 to 5, we're going to have negative. And the last one from on the interval from 5 to positive infinity, you're going to have a positive times a positive, so everybody's positive. All right, so now let's analyze our question here. So here, what we wanted was, we wanted this whole things to be negative. Notice that we have a strict inequality here, right? So if you have an interval notation, then everything should be open. You do not have a closed bracket. Okay, so keep that in mind. So where is it negative? Well, I see a negative to be from -infinity to -5, and then from the vertical asymptote of 3 all the way up to 5. So that's gonna be our answer. Not too bad, right? Hopefully you're kind of getting used to it. So therefore, x squared minus 25 over x minus 3 is negative on the interval from negative infinity to negative 5 open, union from 3 to 5 open. So here you have it. Now if you want to put this on the graphical solution set, then you're gonna have, let me see, here's your negative 5 and 3, 5, so negative infinity here, positive infinity there. So you're gonna have negative infinity to negative 5, so that will be here, and then 3 to 5. Here we go, and that's going to be our answer. All right, since I ran out of room, our actual graph is at the top over here. So notice that again, we do have a vertical asymptote at x equals to 3. I don't know if you can see that okay. Let me see. 3 is right here. So as you can see, there should be a vertical asymptote here. All right. And then notice that our function is negative, or dips down below the x-axis from negative infinity all the way up to negative 5, right? And then also from 3, where the vertical asymptote is, all the way up to x equals to 5. Alrighty, so I'm going to stop here. Good job, everyone. And if you have any questions at all, please let me know.